Hey team, so this is going to be our walkthrough on how to use Google Sheets to calculate your Simpsons diversity index. So let's hop into it. So I have here some sample data from a lichen sample that I took. Some tallies of the different species that I saw are right here in the species count. Okay, so that's what this column represents, the total number of each of these different types of species that I saw. Right here, is the equation that we will be using to calculate Simpson's diversity index. So diversity index is a way to estimate the ratio between richness, the number of species that there are in a community, and evenness, how abundant each species is. Is one species super rare compared to another species? Okay, that might be very common. Okay, it might be more of a dominant species. So in Simpsons, we're really looking at the ratio between the number of individuals of a species divided by the total number of all individuals that were documented in that community. So the closer to 1, Simpson's diversity index will always be between 0 and 1. The closer to 1 the index is, the more diverse that community is. The closer to 0 it is, the less diverse that community. Okay, there's some subtle gray areas between 0 and 1, but that's the gist of it here. So in our formula, we need to first take the ratio between the total number of individuals of each species by the total number of all individuals in that community. So we need to figure out this number first, okay? So add in a row at the bottom that just says total. I've labeled it in here, capital N. And we're going to take the sum of all of these individuals. So equals is a way to basically tell Excel or Google Sheets what you want that cell to do, what you want it to calculate. We wanted to calculate the sum of these numbers right here. And then you close it off with parentheses. And this works the exact same way in Excel. If you're using Excel, that's totally fine. You can do all this in Excel the exact same way. Press enter. So it totaled up all of those individuals, and we have a total of 85. Cool. Now we can calculate this first step. Number of individuals divided by the total number of all individuals equals that number divided by 85. And enter. And you can either keep doing that equals that divided by 85, or shorthand way, click on that, Control C to copy, highlight the rest of those cells, Control V to paste. And it'll copy and paste that formula while automatically moving the row down. All right, in this column right here, we now need to square this. So we need to take this number right here and we need to square it. So equals this number, caret tells us that it's going to wants us to do an exponent function to the second. And enter. And again, Control C, Control V, and it summed it for us. All right. After we've taken the exponent, after we've squared it, then we want to sum it, right? So 1 minus the sum of the square of the ratio between the number of individuals of each species and the total number of all individuals. So now we can sum all those up and divide by, and then subtract that from 1. So let's sum them up first. Equals sum. Okay, now we're to our very end. Equals 1 minus our total. So we took all of these and we totaled them, and that's what we're subtracting from 1. Ta-da! So Simpson's diversity index 0.8266. that's relatively diverse. We'll dive in more into how to interpret this, but the idea here is you'll take this number and compare it to your treatments and see, did that number change? And if so, how in relation to your treatments?